Hi there, welcome back to the breadboard. In our previous video we had discussed about upgrading Marlin on a number of my 3D printers to the latest version 1.1.8. So in this video we're going to do the first one. I'm taking the HCmaker7, which by default came with Marlin 1.0.3 dev version, and we're going to upgrade it because I want to be able to use some of the safety features. I want to potentially look at putting in some different drivers maybe, or auto bed leveling and things like that, and also add features like having manual bed leveling, even at least where you probe 9 points on the bed and things like that, to be able to do some extras and make it a little more reliable. I also want to do this before I start experimenting with other features. There's not much information came from GearBest or made available through GearBest or through HCmaker at the moment for this 3D printer, but there is a bit of information that alluded to what the printer was. Now, in the previous video where I went through some of the technical details, I showed how I used the HJC2560 board, which you can see here, and probed some of the pins from the stepper controllers to the ADIMLab microcontroller to verify what the board type was. And it ends up this is an Ultimaker compatible board. I'm not saying all the connectors are in the same place, but the pin assignments for Marlin is exactly the same as an Ultimaker. Subsequent to me doing that, I've also now had the version of Marlin 1.0.3 dev sent to me from HCmaker. And that pretty much confirmed everything that I had found anyway. So without further ado, I want to get this upgraded so that I can start taking advantage of some of the bug fixes and things like that. Also, I wanted to be able to verify whether any of the safety features were turned on. So first thing I'm going to do is have a quick look at the board itself. Here's the picture here, but we're going to put a bigger picture up of it now. Okay, so here is a large view look of the board. I'm just going to quickly run around it so you can understand what this board actually contains. So we have a 24 volt input here. It says 12 to 24 volts, but the HCmaker7 comes with a 24 volt supply already in. All of the circuitry up here is to do with reverse polarity protection, and also there's a buck regulator providing the 5 volts for the microcontroller and some of the other logic on the board. These three red stepper controllers are the A4988 controllers, as is the one down here. We have X, Y, and Z along the top, and we have the extruder at the bottom. The MOSFETs for the extruder, extruder 1 anyway, or extruder 0 should I say, is underneath this fan. They've added this on the main board to provide cooling for the extruder and the heat bed, as well as the hot end MOSFETs. The other three, all of them have their heat sinks on the stepper controllers. Along the top we have an X output, a Y1, a Y2, and a Z output. We have the limit switch connections. As you can see, all 6 are there. So you have X minus, X plus, Y minus, Y plus, and Z minus, Z plus, but only the minuses are used. So you could reassign the sense pins of each of the pluses for something else if you wanted to, like auto bed leveling, or if you're going to use, say, Trinamics drivers or something like that on here. The two big black connectors are for the LCD display. You don't need to have a header for that. The two smaller ones are, they look like they're for a probe of some kind, and also a, it says PE. So I haven't been able to find any technical information from anywhere that says what these are actually intended for. I've yet to map out the pins to see where they go to. One of them technically could be used for the controlling of a BL Touch or something, for example. But anyway, that's
for another day. At the bottom here, we've just got simply a plus 5 volt output supply. We have the ISP programming header. We have our USB connector. We have a special 12-pin connector. This is something I've only seen on this particular board. They've aggregated all of the connections required for the hot end, the fans for the hot end, and the heater, the temperature sensor, all into one connector. There's one for extruder 0 and one for extruder or heater 1. They're calling the heaters 1 and 2. There's no driver in for the second one because the printer obviously doesn't come with 2 hot ends. There's only the driver installed for the first one. And that's pretty much it. Oh, and you got the ATmega2560 microcontroller, and you've got the USB to serial interface. Now, the nice thing about this board is it comes with a bootloader already installed on the ATmega2560, which means you can program it using the standard serial interface, which makes life a lot easier. You don't technically need to take this out of the case. You could just plug in your laptop or desktop to the USB connection, fire up Arduino IDE, and you can then compile and upload the code. I've actually taken it out so that I could take the pictures, and also because I was mapping out the pins to verify what the board type was. Anyway, let's move on from this. So the next thing is just verifying some of the settings that you need. So what I had what I did was I fired up Pronterface here, and I connected it to the board, and read out, when you first power up the printer, it spews out all of the settings and everything to the serial port. So what I did for the HC2560 board was capture that and note it all down, so that when I did the upgrade, I could verify that all of the important settings are still the same. So here they all are. You can see here that we've got the version of Marlin, the author text strings, the steps per unit. So we've got M92 giving us 80 for X, 80 for Y, 400 for the Z, and 93 for the extruder, so direct feed extruder. Maximum feed rates, acceleration, operational acceleration for printing, retract, and travel times. We have the jerk settings, any home offsets if applicable, heat up parameters. Now the heat up parameters and the actual acceleration ones, a lot of that is driven by your slicer. You can set your temperatures and things in the slicer. These should be set to something that is representative of your printer, but because of all the printers I've got that are basically the same dynamics, with the exception of the Tronxy X5S, which is a Core XY, you could probably leave these all the same settings, or even the default ones. The heat up parameters really shouldn't change for the head for instance, PLA and ABS. But you can see here, well, you'll see when we look at the spreadsheet that there are differences. Anyway, these are the ones for the HCmaker7. Anyway, that's what's important right now. PID settings for the control loop. Now these actually look like they are the defaults for Marlin anyway, and we will have a look at that on my spreadsheet. You can see filament settings are disabled, and that's it. So that's all there is on the basic 1.03 settings. If we look at the spreadsheet that I created, I was telling you about this in the previous video. There's a lot of things. So HCmaker7 is this column here, and as I said, 1.03. The default, by the way, is this one. This is the Marlin default set of parameters as of 1.1.8. So you can see there's a lot of undefined parameters. Anything that's in the bluish or slightly shaded area deviates from the Marlin 1.1.8. I'm not going to go through every single parameter in this list. I'll make the spreadsheet available so you can have a look at it yourself.
and see all the parameters that I've changed or the ones that I've set. I think the most important ones is the bed sizes, the steps per millimeter and things like that have all been retained. Some of the other ones that are not so important or that can be tweaked through the LCD screen have been set to the Marlin defaults for the latest version of Marlin, because I don't see any reason why they can't be at this point in time. I've got other printers that are almost identical to this printer mechanically and electrically, so they're using the default Marlin quite happily. This printer is not suffering from the salmon/tree ring effects that I've noticed, so there's no essential reason except for making it quieter perhaps to upgrade it to using Trinamics drivers. So I'm not going to bother turning those on at this point in time. I will do it for one of the other boards though, so you can see how it's done. The most important thing though is to make sure that you've got all the parameters put into the config file, and I will make the HCmaker7 config file available through GitHub as well as this spreadsheet, so that you can use it for yourself, go tweak it, whatever you like. All the parameters are here that I've changed, and a lot of the ones I haven't changed as well. What I'll probably do before I publish this is I'll highlight the ones that are really important to retain and set up. Maybe I'll put them as a background of red or something like that. I'll change it to red text or something. Anyway, they're all here, and yeah, so let's get to actually doing the programming into the Arduino IDE and get it uploaded so we can have a look at it working. I set that all up in the Marlin firmware, and if I bring this up, here is the Marlin firmware. So for the pins, as I said, I verified already that it's the Ultimaker, so that's the board type we're going to set up. And for the config file, if you go into Marlin firmware when you download it, you just go down here to configuration.h. Now I did create a separate file for the HCmaker7, and I will make that available through my website or through my GitHub account, so that you can just download the config file yourself and use it if you want my settings. But if you don't, you can just go into this configuration.h and program away, and it will give you everything you need. Just change the settings. Either you're uncommenting them or something like that. This is the default one right now, and there are places here like here where you would change the board name to suit the board you've got. So I will have board_Ultimaker in here. You can change the name of your board to something you want yourself. Now let's just go to the, because I've already gone through these parameters, so I'm not going to do it again. Here you've got all the comments for the parameters. But if we go to now Arduino IDE, I'm using, I think, almost the latest one, if not the latest one. And we'll hook up a HCmaker7, and we will update it now to this new configuration. So here it is. You can go to configuration.h and tweak the parameters. I've already changed all these parameters, so because I've set up my own parameters for this latest version, in the author I've put the breadboard CA default HCmaker7 because I haven't added any hardware additional features. Everything else I've left the same except for things like custom machine name. I've set HCmaker7, so when Marlin is ready on the bottom of the LCD, it will say HCmaker7 ready on the screen. A lot of the other ones, they're all exactly as I was just discussing as we went through the file on the Excel spreadsheet. So temperature sensors, etc., etc. It's all set up here. So I think the most important one, as I said, aside from turning on those features, is to have the right board type set. And that is right here. So as I said, motherboard type, board 8 Ultimaker. And that's what will ultimately then pick the right set of pinouts for your board. And I think for a lot of Chinese machines, the biggest issue where they're not being forthcoming with the information or the Marlin software that they've used is they're not giving you this configuration that allows you to do upgrades and tweaks and things to how you want yours to run. And I don't regard this as being another version of Marlin. What I'm doing here is I'm putting in Marlin 1.1.8. All I'm doing is creating a configuration file to suit my hardware. I'm not changing the Marlin code in any other way, the source code anyway. When it compiles, obviously there'll be different components added,
but that really to me is not modifying Marlin. I'm just creating config files and selecting the right board type for my pinout. So those are really the only two things. If a maker has a standard board design, even if they use different edge connectors and stuff, then the pins doesn't change. And if the features that they're turning on and off, it's just this configuration.h. So really the only thing that they would need to provide to us if they're basing it on standard designs is the configuration.h file. And then we can go off and do whatever we like with it. Turn on bed leveling, add a probe quite easily, and things like that. Anyhow, without further ado, let me plug in the HCmaker7 control board and we'll do the upgrade. Okay, so I've got the board in front of me. I'm just plugging it in now. Alright. So what happens is, if I bring up the picture of the board again for a second, the LED right here comes on to indicate that it's connected through the USB, I guess. And down here, the LED, there's an LED down here, started to flash a little bit as well. Now let's just minimize that. So this is the configuration as I've already got it set for the HCmaker7, and we will compile it and upload it. Oh, make sure you've got the correct board set. So in this case, even though it's an Ultimaker within the Arduino IDE, you're picking a Arduino Genuino Mega 2560, and you're picking the ATmega 2560, not the ATmega 1280. Pick your COM port as it comes up for your particular board, and that's pretty much it. You're ready to go. So you just hit the upload button. It will go and compile the sketch. So I'll just pause this while it's compiling, because this is the first time since I powered my machine up that it is compiling, so it might take a few minutes. Hopefully not, but it might. And then we'll come back once it starts uploading. Okay, done compiling. The transmit and receive lights, which are these two here, are now flashing like crazy on the board while it is uploading to the board. Sorry, this one here, it's a blue one. As it's uploading the compiled code to the board, and just takes a few minutes or a few moments to upload it all. And once it's done, we'll fire up one of the pieces of host software and just see what it tells us. There, done. Lights have stopped flashing, so that didn't take too long. Let's just shut down Marlin, IDE. We'll fire up Pronterface. Again, we're on COM24, and let's just say connect, and we should get the board, there we go, to respond. And now here is our new parameters. Let me just copy these and put them in a bigger screen so we can see what it's telling us. So this is the page with it on, so you can see it's confirming it's now got Marlin 1.1.8. Here's the new author, the breadboard CA, default HCmaker7. Today's date, the 15th of May. Buffer sizes, units are in millimeter, Celsius, so these are a few new things from Marlin. Steps per unit, so here's all the parameters that were reintroduced, so they're the same, so nothing should be out of cal from what was there before. Maximum feed rates reflecting the new settings, same as acceleration, printing, retracting, and travel speed maximums. Acceleration for those, they should be fine. Jerk settings, these few here are all settable from the LCD display. Home offsets, I don't have any set up at this point. Mesh bed leveling, now I haven't done the mesh bed leveling yet because we've just uploaded this firmware, so it's showing all these parameters as zeros right now as a 9-point mesh bed leveling. Heat up parameters reflecting the new settings that I used. PID settings are still at their default, and there's no SD card connected, so even the interface is not there, so that's failing. So there's all the parameters back in exactly as they were, but we do now have the latest version of Marlin installed. So let me just go and get this hooked up to the printer, and I'll fire it up and show you the new display. Okay, we're back at the bench. Everything has been put back into the HCmaker7 case. Everything's plugged back in, hopefully the right place. Hopefully I got all my parameters set correctly. So, ready to power this on for the first time since I've done the software upgrade. I know we've had it plugged into the PC and powered up, but that's not quite the same. So let's just plug this in, plug the power in, and let's see what we get. Oh, Marlin 1.1.8, that's perfectly good. HCmaker7 ready, so our little custom machine name worked just fine. Both the temperature sensors are still reading correctly. Let's just zoom in a little bit there and we'll just check some of the menus. Oops, wrong way. There we go. So, we should see some bed leveling. There's our SD card. Let's just plug one in. I've got one here. So I'll just plug it in. It's got some random stuff on it, but it'll tell us if it sees the SD card. There we go. So, and we see the items on it, which is good. Let's go back out of that. So let's go to prepare. So we've got move axes. We'll go auto home. Theoretically, everything is going to work correctly. Let me just zoom out and point at the printer a second. And we'll test the auto home. So, prepare auto home. Okay, good, good, and good. All right, bed leveling. I'm not going to do this properly right now. I just want to see if it does actually the mechanics. So it's on the LCD display. Right there. So I'm just going to select that. And we should go through a process where it's going to control the printer. Let me just put it like that. We should be able to see it. So let's go prepare bed leveling and a couple of parameters. We'll leave those as is. We'll just say load bed, level bed, and it's going to do a home. So it's got that. Now it says click to begin. So let's see what it does. 0.1 of 9, and what you can do now is you can adjust, and I can see it actually the Z steppers are moving so that I can adjust the height. And what you would do is you would get a piece of paper, put it under the nozzle, and you would just adjust. Let's just, I'm going to leave these at 0 for now. I'll redo them at another time. So we'll say OK, and then it will go to 0.2. You would do the same thing there. 0.3, twiddle twiddle. 0.4, twiddle twiddle. 0.5, 6, 7, 8, and 9. Of course, you'd have to make sure your clips are not in the way. And then you're done. And that now says leveling done. Now, I didn't change the leveling, so I didn't really do it, but because it would take too long, I didn't want to bore you just seeing me mess around with it. See, there's the menu, leveling done. And it's just rehoming again. And there we are. Now, the other thing I wanted to have a look at is the nozzle. Now, there's no point in looking at the nozzle for this, but it was the PID tuning. So, home offsets, preheat PLA, preheat ABS, that's all the menus there. Disable steppers, that's all the same basic things. Let's go back up. Let's go to control. See if there's anything new there. Initialize EEPROM, reset file to failsafes, load the settings, store settings. Those are all to do with EEPROM. Filament settings, and temp motion, and then temperature. So it's probably under temperature. And heat nozzle, bed, fan speed, auto temp. And you've got PID settings. You've got PID here, auto tune at 150 degrees C. So let's just pick that. And PID auto tune 150. I don't know if I need to just press OK there. I think it's doing it now. Certainly sounds like the power's come up. Let's go back to the main menu, because if it's running and I just change the display, we should see it there. So we can see the temperature coming up, and it's going to go to 150. You see it's heating up pretty quickly. Now we technically could do this with the bed too if we went in the configuration file and turned on bed PID as well, and then we could auto tune the bed to get it to go be a nice even temperature. But because the bed has such a big heat mass, it would, one, take longer, so I'm not going to do it in this video, and two, it's going to be less likely to be swinging wildly while you're printing. So you can see there it's set to 150, it's gone all the way up to 160. It's turned off right now and it's now cooling down. So it's gone a complete 10 degrees overshoot. Now it's coming down again. It's just come back on. So it went down to 147. It's going to come back up. Come back up to 150 and it's gone back off again. But you can see the overshoot there. Up to 156 this time, not 160. So it's tuning the parameters. It's just come back on again. Coming up a little slower this time. So it's only gone 3 degrees above this time. Come back on, now it's gone below. I'm not sure how many times it will cycle it as it tweaks the parameters. Still running it. And it's done. It's now just turned it off. I noticed that it didn't update the temperature display while it's doing that. Anyway, that's all it takes to do the auto tune. What else do we have? Anything else we've added? I don't think we have. If you look at the PID, we should be able to see the PID settings now, actually. Yeah, so it's 21.5 and 71.07. So they're quite considerably different from the default ones that we had programmed in. But that's because you've tuned it for a specific temperature for that nozzle system, and it's adjusted everything for us. So if you're always going to be printing PLA or ABS, depending on what it is, you could actually tell it to do a tune at the temperature that you want to operate at. Okay, anyway, that completes the video. We've now done the upgrade to Marlin 1.1.8 on the HCmaker7. That seemed to work quite well and fairly painlessly. So, next one up is going to be one of either the Tronxy X5S or the Black Widow. So, and that video should be shorter because I won't go through all the same level of detail as I did on this one. Anyway, if you liked it, give us a thumbs up. If you didn't, well, then don't. If you have any comments, requests, then just leave a comment and I will look at them. I do look at all of my comments. I don't always respond to everything, but I do look at them. And we'll see you in the next video. Bye.